You know that it's going to be a long day. It is going to be packed with some awesome information. So just want to kind of keep us honest and keep you honest. Let's get going on this. The first thing that we're going to start with is a sample lesson. And the sample lesson is going to be on for loops. And so what we're going to do is, in your activity packet, you will find that there is a form there that's going to allow you to, and actually, you know what, I need my, here, and I've jumped ahead. The first thing that I should say, right, is notebooks out, because while we're going to be talking about a lot of great information here, please take notes. It'll reinforce what you're going to be learning here today. Okay, so what we're going to do this sample lesson. We have a volunteer, an experienced volunteer here, who is going to lead the lesson. And what you're going to do, your jobs, you have two. One, this is in Unit 2 of our APCSA curriculum. And so students are relatively new to Java. They probably haven't seen loops of any kind, most of them. That's your context. You are all students, so please pretend for our volunteer who's going to be presenting this, please play the student. Please also, in your activity packet, fill out what we're asking here as far as what is the structure of the lesson. And we talked about this in training 1, right? The anatomy of a lesson. You remember that cat picture? What instructional formats are going to be used? What kind of questioning is being done? And what other techniques do you observe? So again, you're going to be a student and you're going to take notes about what you observe. Come on up, David. I would like to, oh, yes, please. Okay, David Broman is returning for a 7th year with TEALS. He is an amazing TEALS instructor, and in fact, so amazing, one of his students nominated him to be recognized at the UW as an inspirational teacher. He got an inspirational teacher recognition, so congratulations again, David. Okay, all right, everybody ready? Put on your student. Okay.
Okay, welcome to class. Everybody get out your notebooks. Before we start, I'm just going to give you a quick warning. Today's unit that we're starting today is probably significantly more difficult than the unit you just completed. And I would say even more difficult than the unit you're about to start even after this one. So it's important that you not fall behind, you pay attention, you think about what we're talking about, you do the homework, and you give it your all. Because I can assure you of this, the next lesson is going to build on this. And if you haven't really mastered this, the next lesson is going to be very tough. So everybody's ready? OK, I'm going to make a bet. I'm going to make a bet with all of you. I'm going to make a $100 bet that I can write a program to print the first 1,000 positive integers, and I'm only going to use 10 lines or less, maybe 7 or 6. And no, I'm not going to do one long line where I do system.out.println 1 space 2 space 3 space 4 space. I am way too lazy to do that. So knowing that I'm lazy and knowing that it's going to be less than 10 lines, think about whether you're willing to bet me on that. And while you're thinking about that, I'm going to set up the board. So on your notebook, start sketching out how you might do it. Maybe you can factor out methods in an interesting way and call them in a certain way so that in just 10 lines of code, you can get that all done. Give it some thought. Think about whether you want to take me up on the bet. In the meantime, I'm going to write something new on the board. And it's going to match what you have in your packets almost exactly. The difference is, over here, I have a 3 instead of, I think you have a 10 in your packets. Otherwise, it should look exactly the same, except I'm too lazy to write certain things out. All right, everybody know how they're going to do it? I doubt that. OK, what we're going to do is step through this new idea, and I'm going to use some volunteers. So I would like 5 volunteers. And the perks of being a volunteer, as you all recall, are A, I'm not going to make you think too hard. I'm going to make everyone else think harder than you. And B, you get a visit to the cabinet of treasures when you're done. All right, so who wants to be a volunteer? All right, who in the front row wants to be a volunteer? Let's just make this nice and fast. OK, Chris, come on up. Tim, would you like to be a volunteer? Thank you very much. Excellent. And June, would you like to be a volunteer? Great. How about Nupur? Would you like to be a volunteer? Awesome. And how about David? Come on up. Excellent. Let's line up like this. Chris, then Tim, and then keep on going, keep on going. That's great. All right, so Chris, yes. You are going to be our CPU. You are our flow of control.
Okay.
You are the conductor of this symphony. And what you're going to do is to orchestrate everything that's about to happen, arguably the most important job.
Okay.
Okay,
yeah.
So Tim, you are our initializer. Okay, so Chris, as your first task, you're going to walk up to Tim, and you're going to say, Tim, initialize.
Tim, initialize. Okay.
So initializer, you're step 1. I'm just going to number these steps. So Tim, as the initializer, you get control of the marker. And you are going to do this part, number 1, which means you're going to put in our scratch space the letter I. So write out the letter I. Beautiful. And what is the value of I? What is the very first value that you see? Beautiful. Let's have a round of applause for Tim, our quickest volunteer, who can now take his seat. But don't forget to take a prize from the cabinet of treasures that we're making believe exists. Excellent. OK, so now, as our CPU, your next job is now to ask permission to continue. So June, right? So walk up to June and say, may I continue? And June, you should have your arm out here like you're like a parking garage blocker, like no one can leave until they pay. So you're like this. And you say, June, may I continue, please?
June, may I continue, please?
Oh, June, you don't know if he can continue yet. You've got to look at the board. So you're number 2. And you have to figure out if this thing is true or false. So you have this to work with. You know what the value of I is. And you have to ask if it's less than or equal to 3. So looking at that, should he be able to continue? All right, well, I guess you did know what you're doing. Excellent. So Chris, you can continue on. Now you're at Nupur. And Nupur, am I pronouncing your name right? OK. So Nupur is the body of the for loop. And so what you're going to do is ask Nupur, please do the body.
Nupur, please do the body.
All right. So I did promise that I wouldn't have to make anyone think too hard. So let's see. Isaiah, what should Nupur print first if this is her job?
Well, what is she supposed to print out besides just the integers?
Well, this I'm kind of abbreviating. This says system.out.println. So this is really the very first thing she's going to print. And what does this look like to you? What I wrote in between the quotation marks.
That looks like a bunch of hyphens.
Excellent. So Nupur, write a bunch of hyphens. And in fact, before you start, let's cordon off a section of this for our console window. So make a nice huge rectangle. And all of our console output is going to go there. All right, and now print those 5 dashes. And then let's see, Sam, what is the next thing Nupur is supposed to print?
I times I.
I times I. And what is the value of I?
1.
So what's 1 times 1?
1.
1. Awesome. Thank you very much. You can go back in line. And now, Chris, you are done with the body. So now you move on to David. And you say, David, who is the updater. You say, updater, update.
Updater, update.
All right, so as the updater, you're supposed to do that thing to this. Do you remember what plus plus does?
Add 1 to an integer.
Excellent. So what would we put here? All right, very good. OK, so you can go back in line. And now, Chris, here's the interesting part. Since this is a loop, we're learning about loops. You're going to do a little repetition. So you're going to go back up to the condition here, our test. And our condition puts out the arm. And rather than me telling everybody what to do, I think now you're getting the hang of it. I hope you're all prepared. I told you I would start calling on people. So let's see, Jeffrey, what is the CPU supposed to do now?
The CPU is supposed to beg for permission to continue.
OK. Do so.
Please, may I continue?
All right. And she said yes, because 2 is less than or equal to 3. That's great. And then where does he go next, Carl? Okay.
Do your body.
Now it's a little bit harder. Go ahead. See if you remember what to do. Very nice. Beautiful. Okay, thank you very much. Back in line. And then what does he do next? Have I not talked to? Oh, Kimiko. Oh, Kimiko. What does our CPU do next?
He would call the updater to update the value of I.
Come on
Updater,
down.
do your thing.
All right. All right, now I'm going to ask one more person to finish this off for me. So who feels like they have it in their head and they're willing to take a risk and finish this all off for me? What one person is ready to do that? All right, thank you very much for volunteering. Stanley? All right, great. I'm giving you some exercise today. All right, so Stanley, tell us, what is our CPU going to do for the rest of this loop?
Need to ask for the gatekeeper whether it should continue.
Okay.
Can I continue?
And next?
Yeah, and then proceed with the doer.
The body, yes. Do the thing. Hardest job of them all. And then what does Chris do next?
And the updater.
And keep it going. What happens after that?
Then go back to the gatekeeper.
Okay.
Should we
Can
continue?
I go?
No. And that is the end. A round of applause for everybody. Great job. Good listening, everybody. Nice. I want to point out something interesting. I is 4. By the time we're done, I is 4, and yet we have this condition here that says I less than or equal to 3. This is literally, actually, exactly what happens in Java. In order for this condition to have any effect, at some point, that's got to be false. And that means this is going to exceed the limit that we set here. So what you could say is that when this says I less than or equal to 3, this is what we're going to print, and that's going to be the very last value of I. So what if I made a little change? What if I made this be 10? Thank you. I'm used to a magnetic, yeah. OK, so if that's 10, what is the very last number I'm going to print? And what is the very last value of I? Think, and then be prepared to be called on. Last thing I'm going to print, and last value of I. Dibya?
It's going to be 100.
100?
I's value will be 11.
Excellent. So the last time into the body, we had to pass by the gatekeeper, and that means the very last value of I would be 10 at that point. But the loop always ends by doing the final update and then the final ask, can I get back in? And that final update is going to set us up to 11, and then we won't be able to enter at that point. So what I'm going to do is going to give you a few brain teasers. What I want you to do is to think about them, talk with your partner about them, and then be prepared for me to call on you randomly to discuss them. So these are the brain teasers. What if I changed my condition instead of being I less than or equal to 10, I less than 10? What would be the answer to the same two questions? The last thing I print, last value of I. And now I'm going to make it crazy. What if it was I greater than 10? What would happen? Make it crazy again. What if it was I greater than or equal to 0? What would happen at that point? So take a few minutes to think. No, take 60 seconds to think. Then take a few minutes to confer with your partner, and then be ready for me to call on you afterward. How am I doing on time?
Like another 5 minutes, like 9:25-ish. Is
Okay.
that okay?
That's cool. Okay, we're going to assume that you have all had sufficient time to discuss. In an actual classroom situation, I might give you a little bit longer. Thank you for those who are giving me the gift of your attention. Thank you for those who are about to give me that gift. Okay. So first question, I strictly less than 10. What is the last thing we'll print? What will the last value of I be? Who will I pick first? How's about... 10?
Yes. Out will be 81, and then will be the 10 of the final I.
So the last thing I'm going to print will be 1.
Sorry, 81.
81.
Yeah.
I like that better. Great. All right. I totally agree. So with I strictly less than 10, that means the very last time I pass the test, I will be 9. That means I'll enter the loop with I being 9. 9 times 9 is 81. Then I will update up to 10, and then my condition will say no way. So my I got up to 10, but I didn't get into the loop at that point. All right, that was arguably the easier of the 3. Let's move on to I greater than 10. What on earth is going to happen then? All right, who's my next lucky volunteer? Not really volunteer. Oh, I have a hand. I'll take a hand. You don't what about this do you not understand the question, or you're not sure how to figure it out?
I asked to be bigger than 10, and it's not bigger than 10. Do I keep updating until I'm bigger than 10?
Very reasonable question. Very reasonable. Java, I will tell you, is not as smart as you are. So you're looking at this kind of holistically, and you're saying, we want, let's actually write this out, I greater than 10. We want it to be greater than 10, like you said. It starts out being 1. That's not greater than 10. So maybe we need to just keep pumping it up until it gets in the rhythm. But Java's a robot. Java doesn't care about making things be nice and making things be happy. It just does exactly what we think. So we need to follow the exact process. And when we follow the exact process, we start off being 1. And then we ask our gatekeeper, is 1 bigger than 10? And what would the gatekeeper say at that point? Then we're done. So
does that mean I is still 1?
That means the last value of I is 1, and the last thing we print is nothing. We're not going to print anything. This is a loop that never gets entered.
How do you know?
That's a very existential question. So Java will always do this, and it will always ask this question. And then once it realizes it can't enter the loop, it'll just go down to whatever the next instruction is. So whatever happens after that will happen. How did we know that the tree fell? I don't know. We just sort of assume it did. OK, last one. I greater than or equal to 0. So let's do this. 0. All right. Do I have a volunteer, or should I just pick a volunteer? Oh, cool. I get to pick a volunteer. Have I called on Sam? I have called on you before. How about Karan? Am I pronouncing your name correctly?
In this case, the CPU continues to ask the person who lets you know whether you can keep going. And that just continues to happen, and we keep printing things.
So are you saying that this loop will continue on forever?
I don't know. Maybe
like
the computer will crash.
An infinite loop?
Sure.
For all practical purposes, it's an infinite loop. So let's look at this. We start off, I is 1. We ask our gatekeeper, is this true or false? Everybody, is 1 bigger than or equal to 0? Cool. So we do the body. We go up to here. What is I going to become next? Is 2 bigger than or equal to 0? We do the body. then 2 becomes 3. Is 3 bigger than 0? We will continue on and on and on and on. We're going to print a whole bunch of stuff into the console window. The last value of I don't even know. But in reality, actually, it will stop at some point, because there is not an infinite number of integers. It only goes up to about 2 billion or so. So at some point, it's going to get up to the limit. It's going to wrap around to really low negative numbers. And then finally, we're going to stop. But you don't need to know that. What you need to know is, don't write that code. If you write that code, it will run forever, and it's not going to do what you want it to do. All right, great job, everybody. Go to practice it and master it. If you have questions, please raise your hand and let us help you. Wish I got applause in school.
And this is how you become an inspirational teacher. Thank you, David. That was really awesome. And thank you, Allison, for playing the difficult student. Actually, not difficult, but you asked some prying questions. That was really good. Okay, let's take a few minutes here and debrief, because of course, while you were all being awesome students, you also took notes in your packet about the structure of the lesson and a few other things. So let's start. Let's start with the structure part. What did you observe? How did the lesson begin? How did David start? Oh, and let's see, we need microphone. Okay, and so how about we go back there? And say your name.
I'm Jonathan. He started by letting the students know that it would be confusing at first, but future lessons would build on it.
Okay, all right, so laid a little bit of groundwork. Awesome, okay. Anybody else? What else did we see in the beginning? Okay, and I can almost read it. Brad?
He introduced the topic kind of by posing a challenge. He said, I bet you I can write out the first 1,000 integers in just 7 lines of code. And he said, like, kind of think about it while it gets set up. And he introduced the lesson just by trying to get the students to think a little bit.
Right. And money talks. He's like, I bet you $100. So the students are like, okay, I'm in. I want to see if I can win this. What did we call that in when you did the anatomy of a lesson? What component of the lesson was that? Just say it out loud. All right, awesome. Okay, great. So then the progression. How did David progress then through the lesson? He hooked us. We paid attention. Then what? Anybody got anything? Okay. Oh.
Yeah.
Nicholas.
Yeah. So he went on to instruction, actually explaining, what the concept was here, and he did it not just by sitting there and talking, but asking students to come up and doing sort of a live demo of what a loop looks like.
Okay, great. All right, exactly. So he
it
moved
was the
into some
instructional part,
instruction.
but kind of in disguise, because there was a lot of participation from the students.
Okay, so interactive. So there was some interactive component to it. Awesome. Okay. And Tammy, did you have something else that you wanted to add? Okay. Awesome. Okay. And anyway, why don't we go to the end then? How did the lesson end up? Nick? Wait for the microphone there.
It ended with like a bunch of like, hey, what if this? What if that? What if with a bunch of end conditions.
Okay, and actually that is still part of the instruction, but that is very important, right? So David gave us kind of the basics of the lesson as it is in the lesson plan, but he also kind of extended, right, to get the students to stretch and learn a little bit more about for loops, testing their understanding. So honestly, right, it was almost like a kind of a formative assessment that he could ask about these extension cases, and then he asked students, what about questioning techniques? Did anybody notice? Did David? Okay, say your name. Robert.
So one thing that I noticed that seemed pretty effective was that while he had volunteers on the whiteboard to actually walk through all the steps. The questions were never asked directly to the volunteers. They were always asked to people that weren't volunteering to make sure that it's maximizing the interactivity of everyone.
Okay, so you all weren't snoozing sitting out there while David just talked to the people up here. Exactly, exactly. He involved everybody in the classroom. And how did he keep you involved? I mean, you could have chose maybe to not listen, but what did David do to make you like, okay, I really better listen? He was random picking. Okay, he was doing kind of a cold call kind of thing. And I think that's something that we're going to be talking about later today is questioning techniques. But right, I mean, oh my goodness, you're sitting in the second row here, right? I mean, you were probably shaking in your boots. Okay, what else did you notice? As far as, we got questions, instructional formats. Okay, so we talked about that a little bit, right? We had students involved. Okay, and Ethan. Hi, Ethan, it's been a while.
I don't really know what category this falls under, but he was really good about if a student didn't really know the answer to a question of like going the next level down in the questioning. So for like the printing example, he initially asked like, what is the body of the loop going to print? And then he rephrased it as, this is a shorthand for system.out.print, and I'm printing the thing in between these quotes and what's in between these quotes. And so it allowed the student to still feel like they answered the question successfully, even if they didn't get the initial one.
That's a really great, the student still succeeded, right? And it is almost kind of pushing down in the taxonomy almost. And in, David, again, kind of doing that formative assessment and on the fly, being able to adjust his approach, say something else, and again, make the student succeed. That was really, that was brilliant. Okay, anything else particularly effective that you want to share? Okay, right here, Rachel, and say your name.
Hey, I'm Tony. I thought that analogies were really effective. So he used a lot of comparisons, like the CPU is the conductor of the orchestra and the one person is the gatekeeper, so that they can tie the computing concepts to things that they already know.
Right, yes, and good references for students to understand, exactly. Yeah, Adam, back over here.
So he also sort of ramped up his lesson. So in the beginning, he was walking the students through, okay, first we're going to do the initializer, then we're going to check the condition and so on. And then after that, he had individual students walk through individual steps of the loop, and then he had one student walk through an entire iteration of the loop. So it sort of started off with him instructing everyone, and then slowly pushed towards the students demonstrating their understanding of the topic.
Okay, so I do, you do, we do, and then he gave those extended cases, and you all did, kind of thing. Yeah. Boy, David. Was really good. Is there anything that anything that came to you like, oh, maybe this would have been a cool thing to do. I might have tried this in a lesson. Yes. Thank you for waiting for the mic. Stanley.
Yeah, so I'm thinking, so if we visually put an arrow in the comparison, the gatekeeper, point to the beginning of the block and then put the updater to the end of the block, and just to demonstrate where those two steps are happening in the block. That might help the students to connect. Now they have to virtually think when these are happening. At the beginning, when students pick up the knowledge, they may be confused a little bit at the beginning.
Okay, so arrows to show.
Yeah, so which step happens at which part of the block of code.
Yeah, that's a great thought. And actually, that's really great. I know it's a little harder for you to see over here kind of what he was doing. So that's a good catch. Yeah. Tammy.
And in line with that, you could do labeling so that you can see body and have it bracketed so you actually see what the body part is and what the initializer. So actually put those labels on the board so the kids are thinking that way when they see it demonstrated.
Okay. All right. Labeling. Awesome. Yes. Really great. Okay, anything else? Allison, and run, Patrick.
I thought it was really, really excellent. I think the only thing I would have done would have been to, at the very end, write the loop that he talked about at the beginning of printing 1 to 1,000 or something, just to like write a new one from scratch and maybe have the students do it and then like, I don't know, conclude that, because I think I would have been like, darn, I wish I could have seen how that would have worked.
Okay, so it's just following on from that hook kind of thing. Yeah, okay, that's a great observation. Okay, yes, Jai Prakash, right? Oh, Patrick, right here. I don't know if I think the sound still won't pick you up.
Yeah, so here we did talk about, or we walked through the steps here, but I was not able to connect the examples basically. Like I would have definitely told at least 1 or 2 examples from the real life or like how it can be used. Because that's how I will try to correlate for loops, specifically when we are talking about looping constructs. We should be able to for example, if we have in the school itself, if there is an attendance program and there are a lot of people who have to be, some examples should have been told is what I should.
Okay, to tie it in.
Yes.
Okay, yeah.
Because here we did walk through the steps or of how to write for loops, but now how do I use it and why do I use it was slightly missing is what.
Okay, oh my gosh, we have so many great teachers in the making here.
Oh, I'm saying.
Yeah.
And Lori, if I can just offer a kind of devil's advocate point of view as well, we have to be mindful. Our lesson plans are typically for a 55-minute class, and we don't want to cover too much in one class or you start losing, students are going to lose some of those concepts. So totally agree. Examples, real-world applications need to be covered, but perhaps next class. And let's just focus on the fundamentals for this class. So totally agree, but also consider how much content you're trying to introduce just in one class.
Right, and how much time do we spend in instruction again? What percentage of the class is instruction? 25%, okay, right? So David, I think, did a great job of that, and just a great job on the whole. Thank you so much, David. And thank you, everybody. Again, you were awesome students, and you've really, I think, pulled a lot out of this lesson. So thank you. We are going to move on to logistics now.